Hi everybody. What I wanted to do was, I have no idea what's going on here. What I wanted to do is do an example of Cramer's V for you. So I have this example here. So in 1969, Travis Hershey examined the association between the intimacy of a boy's communication with his father and the number of boys' friends who had been picked up by the police. Hershey hypothesized that intimate communications with fathers would reduce the number of delinquent friends. The table below summarizes his analysis. So in this particular table, they did a chi-square test and they found that that test was statistically significant and that its value was 28.77. Find Cramer's V. Now remember that Cramer's V is a measure of association statistics for frequency distributions or frequency tables of two variables with that's categorical. The most important thing to remember about Cramer's V is that it's for tables that are larger than 2 by 2 tables. If it's a 2 by 2 table, then the only thing you need to find the phi coefficient. Okay, so Cramer's V is, let me, come on, go down a slide, or go up a slide rather. So Cramer's V is very simply the square root of chi-square divided by n, which is the total in the sample size, which is multiplied by k minus 1, where k is the number of rows or the number of columns, whichever is smaller. So for us, we know that chi-square is 28.77, right? There it is. And we're going to have to find, and k is the number of rows or the number of columns, whichever is smaller. So let's go look at that table again. We have 3 rows, low, medium, and high. And we have 3 columns, none, 1 or 2, or 3 or more. So since they're both the same, what we're going to see is that k is 3 no matter what, right? They're both the same size. Chi, I'll type this in, is 28.77. And then n, let's see if the table didn't have an n for us. So it doesn't have these total columns. So I'm going to quickly grab the n, and I'm going to do that by simply adding all of the cells together. So let's see. I'm going to get my number pad here to work. 87 plus 53 plus 83 plus 184 plus 88 plus 77 plus 190 plus 85 plus 63. I'm going to look at the top and make sure that I got those right. 87, 53, 83. Yep. Okay. So our total is 910. So, come back. There it is. So 910. So to figure out the Cramer's V, all you really need to do is just plug in these statistics, right? So to figure it out. So what I'm going to do first is go 910 times, I'll put in these, 3 minus 1, parentheses, is equal to, for the bottom half, is 1820. I'm just going to write this down here so I don't forget. All right, and then the top is going to be 28.77. So I guess I wouldn't have forgotten that. It's not like it's a huge equation, but hey, just in case, you never know what you're going to forget. So the next step would be to divide the two. So 28.77 divided by 1820 is equal to that. And then you take the square root of it, boom. Now we have a Cramer's V of 0.13. Okay. Now in order to interpret this, Remember that measures of association are measured by their strength through the categories weak, moderate, and strong. Weak being 0 to 0.29, moderate being 0.3, 0.3 to 0.59, and then strong being over 0.6. So and it goes up. Your measure of association should never be over 1. You can almost think of it like a correlation, only correlations can also be negative. So in this sense, our Cramer's V is weak. And this makes sense, right? If we think about Hershey's hypotheses that boys with better communications with their father would have less delinquent friends. This doesn't make a whole lot of sense to me. The only way it would make sense is if you want to think about boys' communications with their father as a signal of how strong their, or maybe how good their relationship with their father is. And perhaps if they have a better relationship with their father, they're less likely to be involved in delinquent activities. But there's all sorts of factors that go into delinquent activities. And you can have the best family in the world and still like to be a little deviant. So anyway, I can see how we ended up with a very low Cramer's V. So if you have any other questions, feel free to email me.